Dear friends, in this video, we cover part 5 of the topic, A Journey in Fisher's Linear Discriminant Analysis. In part 5, we discuss the Z-score, the computation of Z-score for each of the records, and the confusion matrix and the relative importance of the predictor variables. And let me begin this part now for you. The Z-score equation, linear discriminant analysis, based on the software, is given by the equation Z equal to 0.0153 WCTA plus 0.0183 Reta plus 0.0418 EBITDA plus 0.007 MVEBVTD plus 1.2543 SATA. So in other words, this is working capital to total assets, retained earnings to total assets, earnings before interest and tax to total assets, market value of the equity to the book value of the total debt, and this is sales turnover to the total assets. And the cutoff point score, how do we get it? What we do is we compute the Z-score for each record. For both the groups will be there because there will be 66 companies, 33 companies are bankrupt, 33 companies are solvent, and therefore 66 scores will be there. And the cutoff point score is 2.9714. So we classify, if the Z-score is more than 2.9714, predict the company as solvent. If the score is less than 2.9714, predict the company as bankrupt. And this was done as a pioneering work popularizing linear discriminant analysis by Altman in his classic paper in the Journal of Finance in the year 1968. Now the confusion matrix. Predicted, actual. Solvent, bankrupt, bankrupt, solvent. So 33 cases the model has correctly predicted. Sorry, 31 plus 32, 63 cases the model has correctly predicted. It has gone wrong in 3 cases. Accuracy is 95.45%, fairly robust accuracy. And this was a beautiful paper. I enjoyed reading and actually ran the data set in the software. It's a very wonderful experience. So in the bankrupt cases, there are 33 actually bankrupt companies. 31 the computer has predicted correctly, the model. Solvent likewise is 33. The model has predicted 32 correctly. So the total error, 3 out of 66, which is 4.55%. Accuracy is 95.45%. Which of the predictor variables are important? Can you rank them? Yes. We use the Z-score, Fisher's Z-score, and try to find out the correlation between the Z-score and the predictor variables. We avoid the negative signs and take the absolute terms that measures the strength of the correlation. And we find here the number 1 is retained earnings to total assets because it has a correlation of 87% or so. The number 2 is market value of equity to the book value of the total debt outstanding. It is rank 2. Rank 3 is WCTA, which has a correlation with the Z-score to the magnitude of 73%. And 4th rank is EBITDA. Then the SATA as the 5th rank. As you can see, this is the least important, rather statistically not a significant one, but we told it's important in a practical sense. And this is the ranking. Now, we also do in the analytics the receiver operating curve that measures on the horizontal axis the true positive, and that measures on the vertical axis the true positive, and the horizontal axis the false positive, and the area covered is 95.55, the Fisher's model. And as you can see, it's a wonderful justification or substantiation that the model works pretty well, because this is the divider line. The curve is very, very steep, almost covering all the data points, and therefore the model is robust. And whenever the curve is very close to the divider or below the divider, the model is rather poor. So receiver operating curve, the famous ROC curve, justifies the use of linear discriminant analysis in this particular case of Edward Altman. I hope you have enjoyed the video. Thank you very much. This is the conceptual framework of linear discriminant analysis in 5 parts we have covered. Please go through all the 5 parts to have the holistic knowledge of the remarkable tool discovered by Ronald Fisher, the father of statistics, called the linear discriminant analysis, in short form LDA. Thank you very much. I hope you have enjoyed.